Hi, welcome back all of you. In the last video, we had discussed about the different types of point groups. Today, in this video, I would like to discuss the systematic procedure to determine point group of a molecule. That is, for if you are given an example of a molecule, how can you determine its point group? There is a systematic procedure. That is, we are going to discuss in this video. Okay, welcome back once again. Okay, the systematic procedure for the identification of point groups. The first step is to look for special groups. Special group means you look for if the molecule is a perfect tetrahedral molecule, then this point group will be TD. For example, if the molecule is CH4, then of course it is a regular tetrahedron, symmetrical tetrahedral molecule. Then the molecule will be TD point group. And if the shape of the molecule is octahedral, for example, if the molecule is S sub 6, and that's a special group. So the point group will be OH. Like that, if the structure of the molecule is icosahedron, a regular icosahedron, then the point group will be, you have already studied, that is IH. These are the special point groups or special groups. That is the first step. Okay, if you are given a molecule, you have to look whether the molecule is a special point group molecule like tetrahedral, octahedron, icosahedron, like that. A regular tetrahedron, symmetric tetrahedron, symmetric octahedron, like that. Okay, and that is the first step. Second step, for the look for rotation axis. That is, if you look the molecule, if there is no rotation axis, if it has only a sigma plane, no other symmetry element, only sigma is present, then we have studied that point group will be CS. Okay, and if the molecule contain no symmetry plane and no other rotation axis, it has only inversion center, only I, center of symmetry, then the point group will be CI. Okay, CI is the point group molecule containing only an inversion center, no other rotation axis, no other symmetry plane, only an inversion center, then the point group will be CI. And if the molecule has no symmetry element other than E, only the trivial symmetry element E is present, no other symmetry elements are present, that is highly unsymmetrical molecule, then the point group will be, you have stated, it is C1, because C1 is equal to E, the identity element. Okay, and that is the second step. Examples of we have already discussed, and in the final part of this video we will discuss more about the examples. Now I am telling only the point groups. Okay, and next look for Sn. Okay, it has an improper symmetry element, no other symmetry planes, no other inversion center, but only an Sn axis, then the point group will be S2n. Only it will be an even number. Always this will be an even number. The Sn point group will have always an even number, S2n. Okay, that is the third step. Okay, and the fourth step is uh, you have find out the Cn axis. The highest order rotation axis is there. Molecule contains a Cn axis, and look for NC2 perpendicular to Cn. That is, you have determined the molecule as a Cn axis. That is a proper rotation axis of nth order. Then next step is look for is there any NC2 perpendicular to the Cn. Okay, then this belongs to the, we have already studied, this belongs to the class D group. That is Cn axis and NC2 perpendicular to Cn. Molecule has a higher order rotation axis or nth order rotation axis. Okay, then if there is NC2 perpendicular to Cn, the molecule belongs to the categories D. Okay, And next step is look for whether the molecule has a sigma H plane. Okay, that is molecule has a Cn axis and Nc2 perpendicular to Cn, category belongs to D. And if the molecule has a sigma H plane, then you know the point group will be DNH. If no sigma H plane, then look for sigma D, dihedral plane. If there are n sigma D planes, then the point group will be DND. Okay, if there is no sigma H and no sigma D, molecule has a Cn axis. We have already studied Cn axis, and Nc2 perpendicular to Cn, that is belongs to D category. If molecule has sigma H, then it belongs to DNH. If the molecule has no sigma H but there is n sigma D planes, then it belongs to D and D. But there is no sigma H and sigma D, then it belongs to Dn, provided it has a Cn axis and Nc2 perpendicular to Cn, then category is Dn. That is a fourth step you have to look for. And fifth step, no C2 perpendicular to Cn. You have find out the Cn axis, that is the proper rotation axis of nth order, but there is no Nc2 perpendicular to Cn. Then the category belongs to C category. Okay, then look for sigma H. Similar in the last case, look for sigma H. Okay, if there is a sigma H plane, horizontal plane, then the point group will be CNH. Then look for, if there is no sigma H, then look for sigma D, or we can say sigma V. Okay, then the molecule, the point group will be CNV. Okay, no sigma H and sigma D, but there is a Cn axis. There is a Cn axis and no C2 perpendicular to Cn, but no sigma H and no sigma V or sigma D like that. Then the molecule belongs to the point group Cn. Okay, I think you are clear. Next step is, okay, these are the step, and one thing I forgot, that is the special groups. We have discussed only tetrahedral and octahedral like that. And special group also means whether the molecule, you look for the molecule is linear or not. Okay, then if the molecule is linear, then look for whether the molecule has a center of symmetry. If center of symmetry I is present, linear molecule having center of symmetry, then the point group will be D infinite H. Okay, the molecule is linear but no center of symmetry, no I, then molecule, the point group will be C infinite V. Okay, our special group also belongs to this category also. I forgot in the first case. That is, special group means also the linear molecule. You look for whether the molecule is linear or not. If the molecule is linear, then look for the center of symmetry. If there is a center of symmetry, then the point group will be D infinite H. And no center of symmetry, then the point group will be C infinite V. Okay. And this is a flow chart. You are starting, you get a molecule, you start from here. Step 1. This is step 1. Look for special groups. The linear molecule. If the molecule is linear, then point group will be C infinite V. C infinite V if there is a center of symmetry, or D infinite H if there is a center of symmetry. And the other special group is multiple higher order axis, like tetrahedral, octahedral, like that. And that is step 1. And step 2, no proper or improper rotation. There is no proper rotation or improper rotation, Cn or Sn like that. Okay, then the point group will be C1 if there is no other symmetry element. Point group will be CS if there is a sigma plane, and point group will be Ci if there is an inversion center. Okay, step 3, only Sn, n is equal to E1. No other proper rotation or improper rotation, or sigma planes like that. Then point group will be Sn, that is S4, S6, S8, this is n always will be even. This is a rare point group. Okay, and if there is a Cn axis, not a consequence of S2N, but an independent CN axis is present. CN axis is present. Then, if there is no C2 perpendicular to CN, it belongs to C category. No C2 belongs perpendicular to Cn, it belongs to C category. And if there is a sigma h, then point group will be CNH. If there are n sigma v's, then point group will be CNV. And there is no sigma v's, sigma h or sigma v like that, then the point group will be Cn. And if there is an Sn axis and there are n C2 perpendicular to Cn, it belongs to D category. This is C category. No C2s perpendicular to Cn is C category. N C2s perpendicular to Cn is D category. In D category, if there is a sigma h plane, then the point group will be DNH. And if there is n sigma d's, no sigma h, but there are n sigma d's, then D and D. Point group will be D and D. If there are no sigmas, no sigma planes, no symmetry planes, then the point group will be Dn. This is a flow chart, very simple chart. This is a systematic procedure. If you going through this procedure, you will be very easy. You can find out the point group of the molecule. Okay, we can look for some examples. Okay, determine the point group of the following molecule. Some example, you may ask questions like this in the examination. H2S. You know the structure of H2S is like water. It is a bent molecule. The proper rotation axis is, it is C2 is the proper rotation axis. Okay. So there is C2 axis and there are two sigma V's. A sigma V passing through this sulfur and bisecting these two hydrogen is a sigma V. And another sigma V is the molecular plane itself. So this molecule has a C2 and two sigma V's. So the point group will be, say, what is the point group? Yes, okay, it is C2V. And next is PCl3. What is the point group of PCl3? PCl3, find out the structure of PCl3. PCl3 is NH3. I think it is pyramidal shape. Yes, it is pyramidal because there are 3 bond pairs and 1 lone pair. Okay. So, this will be a pyramidal shaped molecule. Then, look for the rotation axis. First, you can see the rotation axis is C3, like NH3. This molecule is like NH3. So, C3 is the highest order rotation axis. And there are 3 sigma V's. A sigma V passing through this chlorine and this phosphorus. Another sigma V passing through this chlorine and this phosphorus and bisecting these two chlorine, passing in between these two chlorine atoms. Therefore, there is a sigma plane. This is a sigma plane, and another third sigma plane passing through the phosphorus and this chlorine atom. Okay, so the molecule has a C3 as the highest order rotation axis, and there are 3 sigma V's. No sigma H is present here. The sigma H is not present in this case. So the point group will be C3V. Okay, clear. And next is 1,3,5 tribromobenzene. Draw the structure. First you draw the structure of the molecule. 1,3,5 tribromobenzene. Yes, it is bromine is here. This is 3 position. This is 5th position. Okay, in this case, you can see the highest order rotation axis will be the C3 axis passing through the center and perpendicular to this plane. Okay, that is a C3 axis. This is a C3 axis. Okay, then you can see there are 3 C2s. A C2 axis passing through this bromine and in between these two bromine atom. This is a C2 and this is another C2. This is another C2. So there are C3 axis and 3 C2s perpendicular to C3. So the point group belongs to D category. D category. And this is a planar molecule. Molecule is planar. So this molecular plane itself, this plane itself is a sigma plane. It's a plane of symmetry, and that's a sigma h. So the molecule has sigma h, therefore this point group will be D3H. Point group of the molecule is D3H because it has C3 as the rotation, highest rotation axis, and there are 3 C2 perpendicular C2, so this is D category. Then look for sigma h. Yes, of course a sigma h is present because it's a planar molecule. So perpendicular to C3 there is a sigma plane, sigma h plane. So the point group will be D3H. That is a procedure. Okay. Next is XCF4. XCF4. What is the shape of XCF4? Okay. Shape of XCF4. XCF4, there are 4 bond pairs and 2 lone pairs. Okay. So of course the shape of this molecule is square planar. It is a square planar molecule. I think you got the answer. Okay. It's very easy molecule. You know, actually the square planar molecule will have an axis passing through this xenon and perpendicular this plane, and that is C4 axis. C4 is the highest order rotation axis. And there are 4 C2s perpendicular to this C. This is a C4 passing through. I am not drawing the axis because it is perpendicular to this plane passing through this xenon. Okay, there are 4 C2s. This is one C2. This is another C2. Another C2 passing through this 2 fluorine atom, and the fourth C2 passing through this 2 fluorine atom. So C4 and 4 C2s perpendicular to C4. So it belongs to D category. Category is D. Then it's a planar molecule, of course, as in the case of previous example, molecule has a sigma h plane because it is a planar molecule. So the point group, of course, you can easily say the point group will be D4H. D4H, because there are C4 is the rotation axis and there are 4 C2 perpendicular to C4. Category is D, and there is a sigma H plane. Of course, the point group will be D4H. Okay. The next example is chloroform. Okay, of course, chloroform. Shape you already know. This is a tetrahedral molecule. CH is here. Cl. Tetrahedral molecule. But here it is H. The other 3 are chlorine. So it is not TD because it is not completely symmetrical tetrahedral molecule. So here the highest rotation axis, of course, it is C3 axis. It is similar to that of NH3, C3. And there are 3 sigma V's. One sigma V passing through this hydrogen, this chlorine and this carbon. This is one sigma V and passing through these 2, in between these 2 chlorine. So they are reflected because it is a sigma V plane. Similarly, there are 2 other sigma V plane passing through, one through this chlorine, this carbon and this hydrogen, and third one passing through this chlorine, this carbon, this hydrogen, and passing in between these 2 chlorine atoms. So there are C3 and there are 3 sigma V's, no sigma H. Okay, so it belongs to C3V. Point group of chloroform is C3V. Chloroform point group will be C3V. Next is IF5. What is the shape of IF5? How many bond pairs are there? Bond pairs is equal to 5. Lone pairs, of course, is 1. Lone pair is 1. Okay. So I think its shape will be, what will be the shape? Total 6, but 1 lone pair is present. So it is square pyramidal molecule. F is here. F. So square base and 1 F like this. Square pyramidal molecule. Of course, the rotation axis passing through this fluorine this fluorine and center of this iodine. Okay, it is a C4 axis. Okay, but there are no C2s perpendicular to C4. Okay, it is C4, but no 4C2 perpendicular to C4. Okay, perpendicular to this 4, there are now 4 C2s because there is a fluorine here. It's not square planar. If the molecule is square planar, there will be 4 C2s perpendicular to C4. But there is a fluorine. This is a square pyramidal molecule, not square planar. A fluorine is here. So, no C2s are present. No 4 C2s are present. Only C4. Okay, so the molecule belongs to C category, not D category. And the sigma plane, look for sigma H. Is molecular sigma H? No. This is a possible sigma plane, but this fluorine, no counterpart in the below. Okay, if there is a fluorine here, there will be a sigma H, but there is no fluorine here. So no sigma H. Sigma H is not present. But there are 4 sigma V's. Okay, you can easily find out 4 sigma V's here. Okay. Four sigma V's. Yes, okay. This one sigma V passing through this fluorine and this iodine and this 2 fluorine atom. Another passing through this 2 fluorine atom, and third one passing through the like this. This is a sigma V plane, actually like this, and another one in this like this. Okay, so C4, no 4C2 perpendicular C4, category C, no sigma H, but there are 4 sigma V's. So what will be the point group? Okay, say loudly. Point group will be, yes, of course, this is C4V. Okay. Then the next molecule is pyridine. Okay, what is the shape of pyridine? Pyridine shape. Okay, you already know. Pyridine is like this. Okay, then the point group, then the rotation axis, highest order rotation axis is, which is a rotation axis? A C2 axis passing through this nitrogen and this carbon. There is a C2. Okay, and no other C2s are present. No other C2s, only one C2 passing through this carbon and this nitrogen. And there are 2 sigma V's. A sigma V is the molecular plane itself. Another sigma V passing through this C2 axis. Okay, so C2 and 2 sigma V's. Okay. Okay, so the point group will be C2V. Point group of pyridine. Point group of pyridine is C2V. No sigma H is here. Sigma H is not present here because sigma H is the plane perpendicular to the C2 axis. Perpendicular to C2, there is no plane here. So point group will be C2V, not C2H. Okay, next example is ethylene. Yes, what is the shape of ethylene? Ethylene. Okay, C double bond C. H. Okay, what is the highest order rotation axis? Of course, it is C2 passing through this center. This is C2 axis passing through this center and perpendicular to this plane. And there are 2 other C2s perpendicular to this. This is one C2. This is another C2. So C2 and 2 C2s perpendicular to C2. So category belongs to D category. And of course, there is a sigma H plane. This is a molecular plane, planar molecule, and this is sigma H plane. So point group of this molecule is, say loudly, it is D2H. Point group of ethylene molecule is D2H. Then next is trans 1,2-dichloroethene. Trans 1,2-dichloroethene. This is ethene molecule. Trans dichloro 1,2-dichloroethene. Okay, this molecule has a C2 axis. Okay, this is a C2 axis. Passing through the center, you rotate 180 degree, the Cl become here and the Cl become here. So there is C2 axis and no other C2s, no other C2s, only one C2. Okay, C2 axis is present. And this is a planar molecule. C2 axis is perpendicular to this plane and perpendicular to the C2 there is a sigma h. Okay, this is a sigma h plane because it's a planar molecule. It's sigma h. And C2 is perpendicular to this plane. The C2, the rotation axis C2 is perpendicular to this plane. Therefore, this plane is perpendicular to C2. Therefore, it is a sigma h plane. Okay, so only C2, no other C2s are present. So category belongs to C. And look for sigma h plane. Of course, there is a sigma h. Then the point group will be, say loudly, it is C2H. Okay, point group is C2H, not C2V. Okay. Next is BF3. What is shape of BF3? Shape of BF3 is trigonal planar. Trigonal planar. It's very simple molecule. What is the highest rotation axis? Yes, of course, there is a C3 axis passing through the center of this boron and perpendicular to this plane. C3 is the highest rotation axis. And there are three C2s. This is a C2 axis. This is another C2 axis. This is another C2 axis. So C3 and 3 C2s perpendicular to C3. C3 axis passing through the center of this boron and perpendicular to this plane. And there are 3 C2s perpendicular to the C3. So category belongs to D. Then look for sigma h plane. This is a sigma h plane. Okay, so the point group will be, okay, it is D3H. Point group of BF3 molecule is D3H. Next is benzene. Benzene is also very simple. Shape of benzene molecule, you know, this is benzene. And what is the highest rotation axis? Of course, a axis passing through the center of the benzene and perpendicular to this plane, and that is a C6 axis. C6 is the highest order rotation axis of benzene. Okay, and how many C2s are there? Of course, there are 6 C2. This is a C2. This is another C2. This is third C2. 4 C2. 5 C2. And next one, yes, of course, this one, C2. And C6, and there are 6 C2s perpendicular to C6. So category belongs to D. And it is, of course, a planar molecule. Then there will be a sigma h plane. The molecular plane itself is a sigma h plane. So the point group will be D6H. Point group of benzene is D6H. Okay, one more example, the last example. Okay. Yes, next example is, I think we can take allene as the example. The shape of allene molecule is like this. Allene, C double bond C, double bond C. These two hydrogens are in the plane of the board or plane of the screen itself, and the two hydrogens here are perpendicular to this plane. Okay, this is the shape of allene, and you can see there is a C2 axis. The highest C2 axis is here. A C2 axis is present at the center and perpendicular to this plane. And there are two other C2 axes. A C2 axis passing through this skeletal carbon. Another C2 axis passing through this by crossing this carbon. Okay. So C2 is the highest order rotation axis, and there are two C2 perpendicular to this C2. The category belongs to D. But the molecule is not a planar molecule, so there is no sigma h. You can see You can see here there are no sigma H, no sigma H.